Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is all about the summary of the Chapter 9 and the Chapter 9 entitled Transport Layer. Transportation of Data. Role of the Transport Layer. So this is the role of the Transport Layer, responsible for establishing a temporary communication session between two applications and delivering data between them. So the transport layer is responsible for establishing a temporary communication, provides connection-oriented data stream, support reliability, flow control, multiplexing. Transport layer responsibilities: track individual conversations, segment data and reassemble segments, identify the applications. Conversation multiplexing segments data into small chunks. So, segments data into the multiplexing is the segmentation. So, it divided the data into small chunks. Then, label data chunks according to the conversation. Transport layer reliability. Two protocols provided, TCP and UDP. TCP supports reliability while UDP doesn't. TCP supports packet delivery confirmation. There are three basic operations that enable reliability with TCP: numbering and tracking data segments transmitted to a specific host from a specific application, acknowledging received data, retransmitting any unacknowledged data after a certain period of time. The UDP. The UDP provides the basic functions for delivering data segments between the appropriate applications with very little overhead and data checking, perfect for applications that don't require reliability. The right transport layer protocol for the right application. TCP is better for databases, web browsers, email clients, and etc. UDP is better for live audio or video streaming, the VoIP, etc. So, it says here that the TCP is better for databases, web browser, email clients, and etc. The UDP is better for live audio or video streaming, the VoIP, etc. TCP and UDP overview. TCP features: establishing a session. So, it will establish a session, reliable delivery, same order delivery, and the flow control. So, that is the feature of the TCP. The TCP header. TCP is a stateful protocol. TCP adds 20 bytes of overhead in the segment header. UDP features: simple and fast. So that is the uh, features of the UDP. So it says here that it is only simple and it is also fast. UDP header. UDP is a stateless protocol. Reliability must be handled by the application. The pieces of communication in UDP are called datagrams. So the datagrams are the pieces of communication in UDP. UDP adds only 8 bytes of overhead. Multiple separate conversations. The transport layer uh, separates and manages multiple communications with different transport requirements. Different applications are sending and receiving data over the network simultaneously. Unique header values allow TCP and UDP to manage this. multiple and simultaneous conversations by identifying these applications. These unique identifiers are the port numbers. Then the port numbers, usually seen in pairs, source port and destination. So it says here that the port numbers are uh, usually seen in pairs. So that is the source port and the destination port. The source port is dynamically chosen by the sender. So the source port is chosen by the sender, and the destination port is used to identify an application on the server or the destination. Socket pairs. The combination of the source IP address and source port number, or the destination IP address and destination port number, is known as the socket. The socket is used to identify the server and service being requested by the client. Two sockets combine to form a socket pair, the 192.168.1.5 colon 1099, comma 192.168.1.7 colon then 80. Sockets enable multiple processes uh, running on a client or and multiple connections to a server process to be distinguished from each other. Port number groups. The IANA has created three port number groups, well-known port 0 to 1023. Registered ports, the 10242 49151. Private or dynamic ports, then the netstat command. Netstat allows a user to see active connection in the host. So, the netstat command used to see the active connections in the host. Then, nets, netstat allows display the process using the connection. TCP communication process. TCP server processes. Each application process running on the server uses a port number. An individual server cannot have two services assigned to the same port number within the same transport layer service. An active server application assigned to a specific port is considered to be open. Any incoming client request addressed to our open port is accepted and processed by the server application bound to that port. There can be many ports open simultaneously on a server, one for each other active server application. TCP connection establishment. A TCP connection is established in three steps. The initiating client requests a client-to-server communication session with the server. The server acknowledges the client-to-server communication session and requests a server-to-client communication session. The initiating tree acknowledges the server-to-client communication session. So that are the three. That is the three steps to establish the TCP connection. Then reliability and flow control. TCP reliability ordered delivery. TCP segments use sequence numbers to uniquely identify and acknowledge each segment, keep track of segment order, and indicate how to reassemble and reorder received segments. TCP flow control window size and acknowledgement. TCP provides mechanisms for flow control. Flow control ensures that TCP endpoints can receive and process data reliably. TCP handles flow control by adjusting the rate of data flow between source and destination for a given session. UDP communication. UDP low overhead versus reliability. UDP has much lower overhead than TCP. UDP is not connection oriented and does not offer the sophisticated transmission, sequencing, and flow control mechanisms. Applications running UDP can still use reliability, but it must be implemented in the application layer. However, UDP is not inferior. So TCP or UDP. So what you will choose? Applications that use TCP. TCP handles all transport layer related tasks. So the TCP handle all the transport layer. Then this frees the application from having to manage any of these tasks. Application can simply send the data stream to the transport layer and use the services of TCP. Applications that use UDP. Live video and multimedia application can tolerate some data loss but require little node delay. Example include the VoIP and live streaming video. Simple request and reply application. Application with simple transaction where a host sends a request and may or not receive a reply. Example include the DNS and DHCP. So thank you. So that's all for this video. Thank you for watching.